When we start to talk about derivative, the first thing we need to know is its definition. Derivative is a way to show rate of change, that is, the amount by which a function is changed at one given point. So first we need to know is that the derivative of a constant is zero, for every constant is zero. So therefore, when the question asks you the derivative of fx equals to 5, the answer should be 0. Then we need to know some basic rules. First, the power rule. It says if fx equals to x to the m, then f prime x equals to mx to the m minus 1. Here are some really easy examples to help us understand. First, fx equals to x to the 5, then f prime x equals to 5x to the 4. As we combine the power rule to the rule that the derivative of a constant is 0, fx equals to x to the 5 plus 6, then f prime x will equal to 5x to the 4 plus 0, because 6 is a constant and the constant and the derivative of the constant is 0. Every function with power should be worked out by using this power rule. Besides power rule, we need to know the product rule and quotient rule. The definition of product rule is that fg prime equals to f prime g at g prime f. And let's see an example. We just take the derivative of 5x, which equals to 5, and then just copy the x to the 2, add the derivative of x to the 2, which is 2x, and then just copy the 5x. Then we know the answer, and just simplify it. Then we can see another example. Take the derivative of x minus 2, which is 1, and then just copy the x plus 3, and add x minus 2, and then take the derivative of x plus 3, which is 1. Then simplify it, and we can see the answer. Then let's look at a more complex one, the quotient rule. When g of x is over f of x, we will see that its derivative is g of x multiplied by the f prime x minus fx multiplied by g prime x, and then the whole thing is over g of x to the 2. However, since this rule is kind of hard to remember, there is a small tip for you to help you to memorize it. Low d high minus high d low, the whole thing over low multiplied by low. So you can actually sing it out loud. Low d high minus high d low, and it can help you to memorize it. But when you sing it out loud, remember not to make any noise during the test. Then we can look at this example. We just take the derivative of high first, and then multiply it by low, and then minus the derivative of low, and then multiply it by high, and the whole thing over low multiplied by low. Then it comes to the chain rule. The derivative of f gx equals to f prime gx multiplied by g prime x. And according to the power rule, the derivative of u to the n is n u to the n minus 1 multiplied by the prime of u. Then let's look at this example. We took the index 4 to the front. Then 4 minus 1 is 3. According to the power rule, we already took the derivative of f to fx. Then we need to take the derivative of g of x, which is 5x plus 3. Its derivative is 5. Then we multiply 5 after the derivative of f of x. Besides the rules I've talked about, there are some extra equations we need to remember, which includes the derivative for trig and logs. I will just list them all, and then you need to spend time to memorize them by yourself outside of class. After remembering all the rules and equations, let's just combine everything we've learned into one question. According to the power rule, we will take the index 2 to the front, and then 2 minus 1. Then multiply it by the derivative of sine 4x plus 3. Its derivative is cosine 4x plus 3. Then we need to multiply the whole things by the derivative of 4x plus 3, which is 4. The definition of mean value theorem is that for a given planar arc between two endpoints, there is at least one point at which the tangent to the arc is parallel to the secant through its endpoints. Maybe it's not clear enough by just looking at the definition, so we can see this picture. By looking at it, we can see this point that is between two endpoints, and its tangent line is parallel to the secant through its endpoint. The intermediate value theorem states that if a continuous function f within interval a, b as its domain takes the value f and f at each end of the interval, then it also takes any value between f and f at some point within the interval. It may sound vague, but if we actually look at the graph, we will see that as long as the graph is continuous, every point has its own value between the two endpoints.